Okay, we are back and doing our last and final lecture for this weekend session. Lecture number 10. On documentation, garbage collection, and nested classes and interfaces. This is a bunch of miscellaneous concepts. Again, but to kind of finish up, it's about 20 slides. It's not too bad. I'm going to kind of go through it and highlight some things you might be interested in investigating on your own. None of these items will be something that you'll have to program with for this class, but it is kind of interesting to see what other kinds of features are available to you for Java. Java standard APIs are shown in HTML output format, and you can get them online. This URL, actually this is an old URL. You could probably find a more current version of it. It's generated from documentation comments or doc comments that are actually in the code. So one of the interesting things about Java as a programming language is that you can put comments in your source code like you would in C or C++ using almost the same identical commenting style. However, you can run automated documentation for yourself that's built in as a feature for Java. So documentation comments are special comments in the source code that are delimited by these markings here. Same thing you were familiar with in other programming languages. So there's a tool named Java Doc that generates HTML documentation from the documentation comments that you have put in your source code automatically for you. And in fact, I believe Eclipse has an option built into it to create Java Docs as a menu item. You don't have to do this for your programs in this course. However, if you wanted to create very similar, and I don't actually like it, very similar documentation to what the Java, some folks or the Oracle people were doing previously with Java Docs, is they're making it all available. So it's all in HTML format on the internet. So you can go over there and look at all the method calls and all the different behaviors that are associated with different classes and stuff by going through the Java Docs. But I personally find them a little bit hard to read through, and they never really show enough, in my opinion. So I get better information by Googling it and finding other things. But if you want a quick and easy way of creating documentation, just put some source code comments in. The Java Doc utility extracts the information, and the following items are created for you automatically: public classes and interfaces, public and protected methods, public and protected fields and packages. So all the stuff is created automatically using the Java Doc facility. So the doc comments, here's an example. It starts with the 3 characters and continue until the next one. So we have 1, 2, 3 characters will become Java Docs. Other comments, the 2 forward slash lines together don't turn into Java Docs. So you have to use the correct notation if you want it to actually get auto-generated for you. So usually the leading asterisk characters with the preceding white spaces are ignored. So the first sentence of the comment is the summary of the identifier. So you can kind of format your code to sort of, you can format your comments with that into consideration if you want it to read nicely. And you can use most of the HTML tags in the text formatting and provide cross-references, links in the documentation as well. You can use that inside of your comments. And only doc comments that immediately precede a class or an interface field or a field are processed. So you would put them like right before dwin throws this, you'd put the comment right before the name of the method essentially. And if the method inherits doc comments from both the superclass and the super interface, the interface comments are used instead. So most people find it kind of if you're going to do it, you get in the style of doing it. If you don't do it, you don't want like half of it documented and the other half not documented or something. So either people just do it, they just are trained to do it and they just continue putting that stuff in, or they leave it out completely and they never touch Java Docs. Eclipse actually tries to automate it for you a little bit more though, so it makes it a little easier to work with. You can put tags in the doc comments as well. And here's a @C, creates a cross-reference link to other Java Docs. So it's used to see also section at the end of the documentation. So it says, here's the explanation. See also this one. So you can put a tag in there to bring it to another one. So that you're qualifying the operator sufficiently, specify the class name, the interface members, using the pound sign before the member name. So this is get name as an example. If the method's overloaded, List its parameters that might be in there that might be different from the original method. Specify the classes in the interface with their names. If the class interface is from another package, specify that package name as well. So you can also label the entries and the references. A label will be the actual text that is displayed. So here we have get name, attribute names. We can put in, very similar to the get more information link, we have the at link. It embeds a cross-reference in the text. So another way of providing more information in the content of the comment. The identifier specification follows the same requirement. They're both done in the same similar fashion. Changes the value required by all calls, and you put this link in here to the get value, essentially. It's just a cross-reference that you're creating. You can also do a parameter or a return, and all of these tags follow by @ symbols, and then they all have very similar functionality. The parameter documents a single parameter of a method versus a document to document the return value at return. So here it is, essentially tagging certain comments and certain things to become part of the doc. And lo and behold, the throws and the exception can also be tagged the same similar way, so you can document. Or the depreciated, if you're using a depreciated library or something, and now you want to basically put a little notation in there to specify that. The author, the version, since, you know. If you want to, you type in java doc space graphics.java, and it goes through. Java doc essentially is the command that goes through and creates the HTML Java doc page for you, given all the comments that you've put in there and all the tags that you've created inside of the document. So, and again, most people would do this all or nothing. You know, like they would start out doing it and they're required to do it, and then they end up doing it for every single one of their programs, or they don't do it at all. Never done it before and never will do it in the future. It's usually an all or nothing kind of thing. We also have the ability to create package documentation, so that was source code or Java class file documentation. So unlike the Java docs, packages are not defined in source files. To generate package comments, you need to add the package.html file to the package directory. And then you can get package files, and package documentations. So the comments in the package.html between body and body will be read as if they were JavaDoc comments. So you create an HTML file, you put a body section in there, you put the comments in the body of the section, and then if there's questions about the package, this particular information is brought up in an HTML format. So they're not auto-generated, you're really creating it yourself. But if you're using a JavaDoc interface that's going to bring this stuff up automatically, this is the source of where you'd want to document it. You can use the tags to depreciate author, version, but they're not using the package comments. Instead, you're writing, because you're not really using tags, you're just writing your own HTML code that's going to go in there. The first sentence of the body of the summary of the package. The first sentence of the body is the summary of the package. Any of the C's of the links tags must be fully qualified in order to find the class that they're in and the interface that they're in, along with the tag. You can also provide an overview of comments for the source code files by going overview.html to create an outline of it. And just think it's more of a manual process. You're doing the same thing again. You're creating a body section and you're putting the comments inside of the body section, and it's extracted automatically. Comments is displayed when the user selects overview. So that's everything you ever wanted to know about comments, and I know programmers really love using comments, I have found. So, and I myself really love putting comments in my code. So that was sarcasm. I will rarely put a piece of comment in a code. I don't know why, especially when I should be promoting it, huh?
So nobody can understand?
So nobody can understand it. No, actually I don't do it for that purpose. I don't know why I don't do it. I think it makes the code look cluttered. That's my own personal reason. Everyone has their own excuse, though. So. Some places where you work, if you don't put a comment at all, you get in trouble.
Yeah.
They go, "What is wrong with you? Why aren't you commenting everything?" And then sometimes you go into places and you spend half your time thinking about how you're going to word the comments. Or you pick up somebody else's code and you're required to comment it. Huh?
And it's easier to code without putting in comments because it's faster.
It's faster.
But if you want to change something,
it's harder.
It's difficult to change even your own code.
It is very difficult to edit your own code that you wrote yourself years ago. I look at that and I go, why did I do that? And I go, I wish I had just left a little memory behind there. A little comment that told me the reasoning why that method is in there. That would have helped. So I don't know. It's an age-old thing that never has gone away. It's been around since the beginning of programming. Will continue. It's just something we don't like to do. So Java, the makers said, well, let's just make it easy. We'll create this Java docs. You know, my final comment about Java docs? I hate it. You know, because you got to follow a format. You got to put them right before the methods, right before the class. You got to put them in certain spots, and they're auto-generated, so you can't control what happens. And lo and behold, the wrong comment is going to end up with the wrong wording, or the wrong something is going to show up on the first line. And automation, great, but you have to spend a lot of time, and I haven't done it yet. I haven't invested the time to learn the format and get used to it, so I automatically do it on a regular basis. I never create Java docs. So, but don't follow me. I'm a bad example. I don't like comments. So there's some companies that's how they produce their documentation, all through Java docs. And if you don't put Java docs, you don't do any of that stuff, you're not doing your job correctly. Hey, okay. Garbage collection. Moving right along. We always hear about Java not having pointers and not using dynamic memory. Interesting thing is it uses more pointers than I think C++ does. The programmer never has to use it. It's already built in for us. Again, another automation of Java. But for every new, we're supposed to have a delete. We never have a delete. Nobody ever uses delete. We don't have to. Instead, we have an automatic garbage collector that comes and picks up all of the news that aren't being used anymore. So objects are created using new. But there's no corresponding delete operation to reclaim the memory used by the object. If we did this in C++, after about, I don't know, if the program was running for a couple hours or so, we would do new. Maybe by the second or third day, the computer would freeze up or the program would freeze up. Something would stop on us because we'd run out of memory. It's called a memory leak, where we have inaccessible objects, where we have objects that are created that are no longer being referenced. And they create what's called garbage. So garbage is any piece of memory that's allocated that is not deallocated, but it's no longer being referenced. So the JVM knows what's being referenced, it knows what's being used. So it'll go through, and it's called sweeping actually. Go through and sweep periodically. You gotta take a broom out. You wanna go collect garbage? Take a broom out, start sweeping it up, and then you throw it away. So you go through, you sweep up all the pieces that are allocated but no longer being referenced. And then you're doing garbage collection. So when you go home at night, you can do garbage collection. Just pull out a broom and you can do your own garbage collection. So the Java virtual machine uses garbage collection to ensure that any referenced object will remain in memory if it is still being referenced, and free up memory by deallocating objects that are no longer reachable from references in the executing code. So it has a reference list. So it can go through the reference list and say, this one's being used, this one's being used, this one's being used. Oh, here's a piece of garbage, or here's a potential piece of garbage. Are you being referenced? No. Okay, you're garbage. You can basically get deleted. So it's a fairly simple concept, which is kind of interesting why some students find it to be a difficult concept when it's actually kind of easy in theory. It's just nothing you have to do. It's just a concept that's going on. Garbage is collected without your intervention. Nothing you have to do. But collecting garbage still takes time. JVM uses the time. It's something that slows down processing for some people, in their minds, but it doesn't really. Some people never even notice a difference. Garbage collection is not guaranteed that memory will always be available for new objects. You might actually run into a case where you've allocated too many objects. So it solves many, but not all of the memory allocation problems. It's just one solution. So that was your slide on garbage collection. There's no source code examples, because there's nothing you can do. You have no control over it. You can't even turn it off. So you can't configure it. There's no options for it. It's just sitting around in the background, running, cleaning up your memory. Why didn't I add that to .NET? Well, add that to C. You know, there's third-party garbage collectors that you can compile into your C++ programs or .NET programs. They're kind of like sweepers. Well, there's a couple of different algorithms they use. They're just tiny programs that run like demons. They go out there in the background. There's no interface to them. And they go and they just do garbage collection. So you're going to add the modules in your C++ programs. You kind of mimic the same behavior, but again, there's no real proof that those actually work well. So it depends on what you're doing. Plus, if you're using new, you should be using delete in C++. So we just don't have delete in Java. We have garbage collection. Our next topic of choice is called nested classes and interfaces. We've looked at classes, we've looked at interfaces. We haven't really looked at nesting. So classes and interfaces can be declared inside of other classes and interfaces, either as members or within blocks of the code. So we can nest a class or an interface inside of another class or an interface. We have static nested classes and interfaces. So a nested class or interface which is declared as static, means it's a class level, not an instance level, acts just like any non-nested class or interface except that its name and accessibility are defined by its enclosing type. So that actually kind of makes a lot of sense if you think about it. If it's inside of another object, you have to get it through the object. So you go from one type to the other type to the other type if you're going to nest it. Why do you want to nest it? Well, if that object is going to be particularly owned by another object in terms of its behavior, then it makes sense to nest it. In fact, I was wondering, going back to the swing and the AWT, I don't know why they didn't nest all that stuff. It would have made it more confusing, I think, which is one of the problems with nesting classes and interfaces. It makes it harder to find stuff. But if you're not going to create an object outside of the creation of another object, it makes sense to enclose it. And in some cases, you're encapsulating that object inside of the other object. So you nested it. So you're not making it really publicly available when you do that. Although it is publicly available. You just have to get it through the other object. So let's see. Static nested classes and members of their enclosed type. They can access all of the other members and enclosing type, including the private ones, because they belong to it. So if you have a private data member and you have a nested class, static class inside of it, that private, well, it's within the same scope because it's within the class. So outside of the class it would not be accessible, but inside it is, actually. So if you have a private class and you have another class that's going to work closely with it, and you want to make sure everything is private, but you don't want to open it up, for other classes to use it because this other class needs to use it, then you nest it. It's kind of a way of working around the concept of friends. In C++ we have friends. So it's private to everybody else, but if you're a friend class and you have to designate the other class as being a friend, then you can access it. Well, in Java we just nest it. In C++ we can't nest another class inside of a class. Huh? C++ has got friends. Have you ever heard of friends? It breaks the access methods. So it can be private for everybody else, but if you declare the class as a friend, the other class can use it. So, friends, friendly. Oh, there was a joke for that, and I can't remember how it goes. But friends are allowed to access the private members or something or other. I don't know. Can touch your private members or something like that. I don't know. It was some sort of an innuendo with that joke. Something about friends and private stuff. But yeah, that's a great way of remembering it if I could remember the saying. So, obviously it didn't work. So let's see, inside the class, the static nested classes and interfaces can have private packages and protected or public access, while inside of the interface, all of the static nested classes and interfaces must implicitly be public. Serve as structuring the scoping mechanism for logically related types, which makes sense, as I mentioned before. If it relates to it, isn't going to really be used outside of it, put it inside, nest it. It makes it easier. Static nested classes. Continuing on with the concept, if a class is nested in an interface, it's always static, omitted by convention. So this is for a static nested class. If it can extend And extend any other class implement any interface, and it's extended by any other class to which it is accessible. All right, here's some examples down here of a nested class serving as a mechanism for defining logically related types within the context where the types make sense. We have class permissions that is inside of a class bank account. That makes sense, actually, because the permissions is for the bank account. So we're nesting the class inside of it. And it's static, which means it's at class level. So the class is inside, the static class is inside of the bank account. Yeah. Usually we're looking at it from a class as a static from a class method, a static public class that we're going to use. So we can we can access the permissions class. We can actually access this inside of bank account as well. Or we can go bank account permissions and get at bank account permissions as a static class outside of the instance objects. We're doing it for a class level. Only comes in handy in extremely rare cases when you want to nest a class that is associated behavior-wise or functionality-wise, I guess, with another class. In terms of, if we're talking about permissions that are specific, can withdraw, can deposit, can close, bank account. It doesn't have to be nested. It can be separated completely and the same concept would occur. It's just giving you the option of nesting it. You can also nest the interface. So, code outside of bank account class must use, and here's actually what I was just telling you verbally, but bank account dot permissions to reference the class. So, and it's a class level class that is used for purposes of manipulating and controlling bank account. So why not put it inside of the other type? So there are some things that shouldn't be nested when the behavior and the identity of the class object is completely different. So nested interfaces are always static, omitted by convention, since they don't provide implementation, they're just interfaces. So we can get at the interface from the outside at the class level. Non-static classes are interclasses. Interclasses are associated with the instances of its enclosed class. Every instance of an object that is created also contains the objects of its subclasses. So just think you get all of it in one. You're creating multiple objects simultaneously when you create one instance of the outer class. Here we have bank account. Now we have class action, and action is going to do some stuff on the bank account. And we have some methods to deposit, to withdraw, essentially inside class action. So, private action, last action performed, keeping track of that. So it's a way of dissecting out, if you want to think of it more than the concept of dissecting out and formatting the belongings or the enclosing or the abstraction of the behavior in multiple classes and keeping it all housed under the same roof. It's pretty much accomplishing that.
So can outer class access to memory variables of the inner class?
Yeah. And vice versa.
And the inner class can access the variables of outer class?
Yeah. It's within the same scope, even if they're private. Yeah. Private, public, everything. That's going to be private. The data members are going to be private, but the inner class can access them because they're inside of the class. It means it's in the class. It's a subpart of the class, but it's really in the class. Think about it. Inner classes. An inner class object is created. It must be associated with an object of its enclosing class. That's the one rule breaker. Not rule breaker, but interesting thing. You can't make an object of an inner class. You have to make an object of the outer class, and then you get the outer class and the inner class. So you don't nest classes when you want to make objects of them outside of the use. So if you had the idea about permissions, you can't make a permissions object without making a bank account object if you nest it. Which is kind of good, because then if you were using permissions only for the bank account, and it was specifically designed to be working with the bank account, every bank account object would automatically include a permissions object. So when you make one, you make them all. You make both. But you can't make the inner without the outer in that case. So you have to sort of think about the concept of whether or not you're going to be using it with the other object or whether it's a standalone object. If it's not a standalone object, nest it, and then you've got it enclosed in another object. Why do you want to make two objects out of it? It's just basically going back to what I said about dissecting the behavior, giving the identity of a permission related to permissions objects and behaviors and methods, so you can remember the abstraction a little easier than a bank account. A bank account is a pretty broad concept in terms of the identity of that object. So using the inner class objects are created inside of instance methods and enclosed classes. When this occurs, the current enclosed object, this is associated with the inner object by default. So the last account is this.new action. So this is everything, the inner count, associated with the inner class as well. When deposit creates an action object, the reference to the enclosing bank account object is automatically stored in the action object. And using the saved reference, the inner class object can refer to the enclosed object fields directly by their names. That's the inner object going to the outer object and vice versa. Full name will be the enclosed object this preceded by the enclosing class name. So this dot number, bank account dot this dot number for the inner class to look at the number for the bank account. So return that. So basically you get it where it is by its resolution of its class. Is it bank account or is it permissions dot whatever it happens to be, the data member or the member function that you're trying to get at. It's just another way of resolving the resolution. Any enclosing object can be substituted for this, keyword this. Here's an example. Suppose a new account named transfer is added. Void transfer. We have other, where's this in here? Here it is, this.new.action. So this object, everything inside of it, .new. Don't worry about it. You don't have to program in this stuff. You probably will never program in this stuff. It's hard to see inner classes, and you don't ever have inner classes whether static or non-static, unless you have a special purpose for it. It's like one of those things that you won't do until you actually find a need for it. And it only happens maybe 10 or 15% of the time. It's not a really big thing that most people would actually program with. In terms of the inner class, the enclosing class can also access the private members, as mentioned before, of its inner class. So it works both ways. So if it's private on the inner class, it's public for the outer class. It's no longer private, but only the explicit reference to the inner class object, which you have to do anyway. An object of the enclosing class need not have any inner class objects associated with it, or it could have many. It doesn't necessarily have to have any objects associated with it. Inner classes act as a top-level class, except that it can't have static members except for final static fields that don't change. So final basically says it doesn't change. It's constant. Inner classes can also be extended. So here's some inheritance, scoping, and hiding. This I'm not going to get into. I never get into this. Because most people can kind of catch the inner class concept. In terms of the inheritance, scoping, and hiding, all members declared within the enclosing class are said to be in the scope inside of the inner class. So the inner class's own fields and methods can hide those of the enclosing object. Two ways of hiding it if we want to. Not going to get into the two ways, don't worry about it. Let's see. Not going to get into local inner classes either. It's just, or anonymous inner classes. If you have an interest in this, it is not on the final exam, by the way, and it is not anything that you have to know for any of the assignments either, or for any of the object-oriented concepts of this course. This entire concept of inner classes. I'm not going to ask you any questions on it. There are the concept of garbage collection, yes. The concept of the Java docs, yes, in the first part of this lecture. But the second part of this lecture, and we're on like the last slide or so of this lecture, Doesn't get into enough detail to do it justice, but the concept of the inner class is kind of interesting to know that we have that capability. That's what you want to take away. So that if you ever come into a case in which you're thinking, you know, that might, can I put a class inside it? Yeah, you can put a class inside of a class. And that it's nested in terms of interfaces and classes. We also have anonymous classes. They don't have a name. So you declare an anonymous class that extends a class to implement an interface. You don't have to know about anonymous classes either. The type of the classes are defined by the same time they are instantiated with new. So return new iterator. Actually, we've had anonymous. I've shown you examples of anonymous method instances of classes. And you just don't give it a reference variable. Just say new person. And it creates an anonymous new person without any reference, so you can't really get at it. It's just an object that was created. You can do the same thing, essentially, inside of the inner classes. You can create anonymous inner classes. They don't really do any, aren't getting at by name. Because if you think of the concept of the interclass, it's for the special purpose of use by the class normally. You're not really going to reference it that much anyway. It's going to reference the outer class, but you're not going to really reference that. It's going to be part of whatever object you created. Nesting inside of interfaces, very similar to classes. Reason for using nested interfaces inside the class. Associates types that are strongly related to the interface inside that interface. Okay, so it's not used, interfaces are used for a slightly different purpose than inner classes. But you can also do it to define or partly or completely define default implementations for that interface. So the class implementation of the interface can choose to extend the default implementation or follow it in another way. So any class or interface nested inside of an interface is public and static. Well, interfaces have to be public. That's how you're gonna extend the behavior if it's not. So interfaces are implemented so that you can implement layout methods that are part of the interface of being part of that concept of that type of object. So by default, they're public. Modified variables in interfaces. I'll save you that. So you don't have to worry about that either. So that was lecture number 10, which was the last lecture for this course. Lecture number 11, let me simply bring it up to show it to you because some people might be interested in it because there are some questions on the final exam, which I'm going to be talking about in a few minutes, that would be useful to know. I would highly recommend for the midterm and also for the final to take a look at this lecture. You're like, well, what does this lecture do? No source code, no programming, nothing. Instead, this lecture gives you putting the pieces together, looking at object-oriented concepts. I'm not going to go through 166 slides or so. I'm just going to briefly spin through the design concept, abstraction, polymorphism, inheritance, encapsulation. It's a really nice summary of object-oriented concepts in general, in terms of what it is you wanted to learn, in terms of why we're programming this way. The object concept, object types, object created, subclasses, superclasses, defining objects, the state, the identity, the state, the behaviors that are associated with objects are discussed. Also the concept of the class and the object and how the object is an instance of the class. See, some of this stuff is really basic, but it's a nice overview. The properties that are defined, instance variables and class variables, instance methods and class methods. And you know the differences, hopefully. Instance variables belong to instances of that. Each individual instance of that particular object that's created holds their own value. Class variables and class methods are run on all of the objects that are created of that particular type and runs from the class level instead of at the instance. Concept of messages and methods associated with running functions. Functions are their methods that we're creating. Instance methods, class methods. And there's some examples with this here. What do we got? The benefits of object orientation in terms of the modularity, breaking up the functionality into separate different classes. The concept of information hiding, and how that's, you know, we have a public interface, and then we have the private data members inside of the class that provide a protection against the class. So, gives us our information hiding. We don't necessarily need to know what the method does. All we have to do know is run the method. We don't know what data is being manipulated or what data is being changed. So, polymorphic behavior in terms of, by definition, the ability of the object to respond to the same message in different ways. If your vocabulary of object orientation is a little weak, you want to review this lecture before the final, because a lot of this vocabulary is being used. Like polymorphism, you want to know what inheritance is, what polymorphic behavior is, what encapsulation is, what does abstraction mean in terms of how it's implemented, and specialization in terms of inheritance. The concept of inheritance, like I say, this is all concepts and vocabulary, no programming in this lecture. The superclass, the subclass. Inheritance, you might say, facilitates reuse. So a lot of people call reusability as part of the information hiding. Information hiding and reusability are kind of counter components of inheritance and encapsulation. Encapsulation promotes information hiding, and inheritance gives you reusability. So, inheritance examples with a derived class are rectangle, circle, and triangle from an object. Same thing with the BMWs and the cars. Making new objects of existing objects and inheriting them. The views of the class, the public, the protected, the private. You see public and private used a lot in terms of keeping things visible to the client, and the client here is the driver program, sometimes referred to as the client. So, protected means it's visible to subclasses of a class, but not to the public. The constructors, no deconstructor, not in Java. We do not have a deconstructor, we do not have a copy constructor. In Java, we only have a constructor, because we have automatic garbage collection. It's just defined. Without garbage collection, we need a destructor, because when the object goes out of scope and it has allocated memory, we need to deallocate it. How to access static methods at the class level. How to access data. Let's see. Object terminology, inheritance, base class, superclass, derived class, composition, and that's pretty much it. So the lecture itself is kind of a review of, it's only 68 slides of object orientation. So let me give you a summary of what to expect next time. So this lecture is going to conclude our weekend in my Java. I can see my YouTube did not work, so I will go back to bhacker.com if I have internet access. Leave the page. I do. Very good. Okay, so in here, if you have not noticed, the midterm exam is here. The midterm exam is what I went over last time. That actually, that last lecture might help you. I went over the midterm last time. Probably the Sunday of that weekend. I also may or may not have gone over the CSLO essay. Did I go over that? Let's take a look at the CSLO essay. The CSLO essay, the midterm exam, I'm pretty sure I went over. The CSLO essay, Course Student Learning Objective Essay. In the old days, it was a different format, which is why I sort of want to go over it just to make sure we're on the right track. In the new days, it's an essay. You're writing an essay to see what you have learned, and it's kind of a self-reporting tool where we're going to view this at 200%. Let's see. I think I did go over this actually. You're writing a 3 to 5 page double-spaced essay where you're selecting a topic. You're selecting one of the 5. Don't do them all. I have had students answer them all. Select one of 1 through 5. Write 3 to 5 pages double space, which is 1.5, or 1 page single space. I don't know, 1.5, I guess, to 2 or 3 pages. Do a double space on your selected topic. You need to include at least 3 reference citations. Any referencing citation format you want to use, APA, MLA, whatever it is you want to do. You can reference stuff on the internet. See if you can properly use a reference citation. Which means you don't actually have to quote inside of the paper, like so-and-so said this, or so-and-so said that. Instead, if you want to, you can leave it quote-free, no quotes, and then at the end provide what's called a reference list, and in there put the 3 sources of information that you found. Do not cut and paste your paper. That's not how you're supposed to write a paper. Write it yourself. Paper should reflect your own writing and cannot contain portions cut and pasted from internet sources or other sources. I've had students cut and paste and then give me the sources. You're defeating the purpose. You're supposed to write this paper yourself. And papers are going to be turned into turnitin.com plagiarism. You don't have to do that yourself. I have an automated system that's going to do it for you. If the paper ends up being plagiarized, which is more than 50% matching, so I use 50% as the ratio. I think it's pretty high, actually, which most papers will pass. You'll receive 0 credit and no opportunity to do it again. This is your opportunity to practice writing professionally academic quality papers in English. Helps your English skills. So your topics are your selection topics. Pick one. They're pretty broad, and sometimes they might overlap a little bit. As an example, the concept of object-oriented modeling, use of Java for web-based tools. We didn't really cover that in class. Or client-server computing. Didn't really cover very much of that. So it allows you to pick a topic that I haven't really covered very much and do some more research on it. Kind of learn a little bit more about it. Compare Java object-oriented language with another object-oriented programming language. That one might be an interesting one. Compare it with C++ or something. Demonstrate how to solve a given application problem. This is a very popular one, but don't give me the source code. This is popular because students can just write 2 programs, or write a program, and they solve an application problem. You just kind of paste some source code that you wrote. It's supposed to be a writing paper, so you're supposed to write an English paper. So if you choose number 5, and you're demonstrating how to solve an application problem, do not give me source code. It says you do not need to create the Java source code, but provide the logic of the program design and explain why it's a good design and how the object-oriented concepts are applied. It's an English writing paper. I don't want to see source code for any of these. Unless you have small little source code examples. As an example, you want to show something about the EE Enterprise Edition, you may put in snippets, source code pieces. This is how you create the object. This is how you inherit the object. This is the class you use. You can do that if you want. But make sure the paper is a majority written writing assignment. The CSLO is not due until the very last day of the course. Technically, our very last day of the course is October 29th and 30th, but as I mentioned before, you have the deadline that the weekday class will have, which I don't know yet. It's at the end of November. That's all I know. I haven't really set the date yet. But this particular assignment isn't due until the end of November. If you want, you can turn it all in early. However, right now it's kind of impossible to do that because the LMS doesn't accept assignments yet, which means you have to kind of queue this stuff up anyway. So the midterm and the final exam are a significant portion of your grade, although I have been talking about the assignments for a majority of this class meeting. The bigger part of your grade is in the final exam, the midterm, and the CSLO. So that midterm is 25%, the CSLO is 25%, final is 25%, homework is only 25%. So you can only get 5 points extra by doing the 5th assignment. You do 4 of them, you get 25%. Which means you're going to want to show up for the final exam. And as I mentioned to you guys yesterday, if you take the exam, and here's a little another piece of information, the class meeting that will occur at the end of this month, on October 29th and 30th, you only have to show up for 1 of the 2 days, and you only have to show up for a couple of hours, actually. So if you're taking another course that meets on the same weekend, you can take the exam at lunch hour, or before, or after. I will probably be holding the exam from 10 o'clock in the morning till 3 o'clock in the afternoon on both days. You won't be assigned a day. Pick a day. Pick a day and show up. If you're not taking the exam on the 29th or 30th, you don't have to show up. But you will have to show up at the end of November. I don't have the schedule for that yet, but it will be held on a Monday or a Wednesday. So it won't be on a Saturday. You cannot take the exam on a weekend day unless you take it on the 29th and 30th. If you take it on the 29th or 30th, you're going to get a multiple choice exam. And sometime between now and the next 2 weeks, I'm going to write the exam. And after I write the exam, I'm going to put together what's called a little study sheet, a little review sheet, and I'll put it out on the behacker.com website. And I'll have the TA send a message out to you guys to let you know when it's available, just to confirm that. And that will have the content of what you should study for. It'll probably be a Word document and it'll just tell you, know this concept, know that concept. And I'm pretty good at telling you ahead of time what to know. So then you study that, you come, you take the exam, it'll be multiple choice, it's over with. If you wait, which is your option, you'll have a different exam. You have to take a different exam at the end of November. You have to take it with the weekend session, and I know I always put programming on that one. I always make that one a little bit harder than because this one is only 1 month into the class, or 2 months into the class, so. This is going to be more concept-based. The one for the weekday class will be it won't be that hard, though. I mean, write a class, inherit a class from a class, use an interface with a class. You know, it's just basically testing more of the hands-on versus the theoretical. So if you like the hands-on versus the theoretical, you don't like multiple choice, some people don't, then wait, come here in November, end of November, take the writing one if you want. So I haven't decided yet, but I might open the option up to the other session. If they want to take it early, they can come and take the theoretical one instead of the hands-on one. So we'll see. I don't want everybody, not everybody's going to show up though. I mean, it's just another 4 weeks from now. This is like the first weekend in October, so we're looking at the last weekend in October. 4.5 weeks in October. So not that long ago, not that far away. So I don't think they're going to want to do it seriously because we're not even halfway through that course yet. So let's see. So I talked about the midterm exam last time. Just told you about the final exam. It is in person. You do have to show up. No notes. It'll be a closed book, closed note. It'll take you an hour to 2 hours. Depends on how long it takes you to read. It will be approximately, I don't know, 25 to 30 questions. I like to make more than 25 questions and I have 1 point each, and so I can drop out 5. Gives you a little leeway just for bad questions. So it'll be out of 25 points. So I don't create extremely long exams. For some of you who've taken my classes before, you know that already. All the homework is not due until the very last day of the course, which is the last day of the weekday section, which is at the end of November. I will have the TA send out messages even after the 29th to remind you to turn stuff in before the end of November. And we'll have the exact date as we get closer. I don't know the exact date yet, unfortunately. Anything I missed? Any questions? Because this is pretty much the last time I'm going to see you until the final exam. Your last day of the last weekend of the last session before the final exam. And we covered everything we needed to cover, actually. We're good. The entire semester in 2 weekends. So if there aren't any questions, you're done. We ended up, 2 o'clock, so that's pretty close. I'm going to stick around a little bit. So if you have any individual questions, you can come out and ask me. We can talk about stuff. Otherwise, if you're not going to be here for the next meeting, I don't need to know. If you decided you're not going to take the final exam, you don't have to tell me. If I don't get your final exam, I'm going to know you didn't take it. And I'm going to assume that you're going to take it at the end of November. If you don't take it at the end of November either, then you're going to end up with an F in the course. Actually, you're going to get 75% if you've aced everything else. But most likely, if you didn't take the final exam, you probably didn't turn in the midterm. All you have to do is miss one other item and you got an F. If it's 25, 25, 25. I don't care if you turned in all the assignments. It's not going to matter. If you missed the final and missed either the CSLO or missed the midterm, that's 50%. That's more than 50% of your grade right there. So, only 25% on the homework. So if you can't do the homework, don't worry about it. You only would be in class. But there's no excuses. You should be able to do the homework because I gave you all the answers to the homework. So, any questions? I feel like I kind of went through it too fast. No? Then enjoy the rest of your day. We're done.